Heidi-ho, Renaissanceteers, and welcome to the solution to Renaissance puzzle number 189, tackling the tetrahedron. The object of this puzzle is to determine the height A of a tetrahedron with all sides equal to 1. Let's begin by noting that the vertical line from the peak of the tetrahedron to the center of its triangular base, shown in green, meets the base at a right angle. If we draw a dotted line of length B from a corner of the tetrahedron to the center line, we form a right triangle with hypotenuse 1 and sides A and B. So if we can just find the length of side B, we can use the Pythagorean theorem to find the height A. Let's take a look at the triangular base from squarely above. We know that all three angles of an equilateral triangle are 60 degrees. Line B bisects the third angle into two 30-degree angles. Now let's draw a vertical line down from the center point, dividing the triangle side into two lengths of 1/2. Note that we have formed a 30, 60, 90-degree triangle. We learned from the tiny triangle tutorial that the ratio of the sides of a 30, 60, 90 triangle are 1, 2, and the square root of 3. So this tells us that B is to 1/2, as 2 is to the square root of 3. And this simplifies to B is equal to 1 over the square root of 3. So now that we know that the length B is equal to 1 over the square root of 3, figuring out the height A is a piece of cake. Pythagoras taught us that A squared plus B squared is equal to H squared. Solving for A, we get A is equal to the square root of H squared minus B squared. Plugging in the known values for H and B, we get A is equal to the square root of 1 minus 1/3. And finally, this simplifies to A is equal to the square root of 2/3. Quod erat demonstrandum.